Hello class, this is a video tutorial on specifying the terminology and understanding of calculus. The first key thing you need to know in terminology is what is the derivative. The word derivative is a noun and it is the gradient of a function. The derivative, what the derivative does, it finds the gradient of any tangent along the graph of the function. The second piece of terminology you'll need to learn is to differentiate. This is a verb, and in math, it is the process of finding the derivative of a function. And currently, at this point in our understanding, the only method we know to differentiate functions is through differentiation by first principles. And we do that by following this formula here. So let's go through some more examples as we do it here. So how I like to teach it here is we find this first expression. This is actually one of the harder ones to work with. Okay, so we find f of x plus h. Since our function is x squared, we substitute x plus h into this expression. We expand this, square the first, square the last, double the product. So once we have this expression, which is one of the harder things to find whenever students do this, we now just simply follow this expression. So f prime of x is equal to limit of h approach 0. So the limit as h approaches 0. We'll put the fraction first, all over h. F of x plus h, we found the expression of, is right here. So we're just going to copy that in. So x squared plus 2xh plus h squared minus f of x. So minus f of x is this expression here. So minus x squared. From this point, it's just a matter of algebra. X squared minus x squared, those two are gone. All we are left with is this 2xh plus h squared. So let's copy everything we haven't done. So limit as the h approaches 0. And remember, these two are now gone. We are left with 2xh plus h squared all over h. I'll draw a line so we can follow to the next line. From this point, we can see we can factor out h on the numerator. So the limit as h approaches 0, h outside of 2x plus h all over h. From here, we can cancel out the h's. So we are left with limit as h approach 0 of 2x plus h. And at this point, since we have reached the end, we are now going to apply the limit as h approaches 0. And as h approaches 0, it just equals 0. So it just is eliminated. So the gradient is given by 2x. So if we have the function f of x, the gradient of this function is 2x. So now let's see what this derivative actually does. So let's find the gradient of the tangent at x equals 2. So this can be notated as f prime of 2. So this means the derivative of the function f, what is the gradient of the tangent drawn at x equals 2. Okay, so what this means is if I go to x equals 2, I find the point that this is on the graph of the function, so this is x squared. At x equals 2, if I draw a tangent at that point, like so, what is the gradient, or what is the rate of change of the tangent at that point? Well, this is what this does. If we just substitute the value of 2 into the gradient function, or the derivative, so it'll be 2 times 2. F prime of 2 will give us 4. So the question we asked earlier, what is the gradient of this tangent? Well, it's a gradient of 4. Don't be mistaken by this value here. This is the function value of 4. So the y value here is 4. But the gradient of this tangent is also 4. So let's do this again. So when it asks, what is the gradient of the tangent at x equals -3, this can be found simply as f prime of -3 equals 2 times, and remember we got that from this derivative, and all we're doing is we're substituting -3 into x, so -3, so f prime of -3 is -6. So on the graph, what this indicates is this: at x equals -3, we're going to draw a gradient at that point, or a tangent at that point. So drawing a tangent at this point. If we could measure the gradient of that orange tangent, the gradient of that tangent would be -6. So let's do this one last time. What is the gradient of the tangent at x equals 4? And once again, we can just find that by substituting 4 into the derivative. So f prime of 4 equals 2 times 4 equals 8. And so once again, graphically, what that means is if we were to go to x equals 4, go up to where this hits the graph of our function, and we draw a tangent at that point. What the derivative does is it tells us the gradient of that tangent at the point 4 by substituting it into the derivative, which could also be called the gradient function, because it gives the gradient, as it says here. The derivative finds the gradient of any tangent along the graph of the function. All right, so I hope that gave you an insight into the terminology of the derivative and what it means to differentiate. Okay, I hope to see you in the next video where we do another example here. Hope to see you then, and best of luck.